All right, here we go. Real zeros of the polynomials, okay? We're going to finish up these notes on 4-4, and then we'll talk about 4-5 Thursday, and then that PS won't be due until Friday or Monday. All right? So, students missed it from the earlier class. So, rational numbers. Remember, the rational numbers can be expressed in the form a over b, where a and b are integers, b does not equal 0. Your rational zero theorem. So this is a way that we can kind of find out what the possible rational zeros are. Just because you have a polynomial doesn't mean you have to have rational zeros. Okay? So this long equation here, are you not drawing? There you go. Is it just means, 3x squared plus 2x plus 7. Or maybe it goes x to the 5th, x to the 7th, whatever. Every rational zero is in the form of p over q, where p is a factor of the constant coefficient a0, q is a factor of the leading coefficient an. So the book will use p and q. That's what pretty much you'll see in every single book. What I like to use is I like to use c over a. Because if you think of p over q, you're like, oh, p over q, p comes before q, p's got to be the first term, q's got to be the last term. And it's the opposite. P is the last term, or the constant, and q is the first term. Okay? So I like to have it c over a, and what can happen? It'll be plus minus c over a, all the possible roots. Okay? So roots, they're zeros, same thing. So to find the rational roots of your polynomial, number one, there's your plus or minus. Factors of the constant term over factors of the leading term. So this is your C and this is your A. And then second thing you do is use synthetic division to see if it is truly a zero. Okay? So find the rational roots of the following. What we have to do first is list the possible roots. So my possible roots are plus or minus c over a. This one's kind of easy. Who? Okay, sure. All right. So C, it's all the factors of 2. Are you like a little owl? So they're 1 and 2. Who? 2. Okay. And the factors of A are just 1. That's it. Okay. So these possible roots are plus or minus 1 and 2. So there's 4 possible roots. Okay. Now what you have to do is you'd have to plug them in. So we'll just start with, we'll show 2. Okay, just to show you what happens. So you have to make sure, remember, synthetic division, we're going to try 2, but it has to go in descending order. So I have an x cubed, an x squared, which is 0, an x, and your constant. And what has to happen? We need this to be 0. Okay, so you need that to be a -2. Okay, in order for it to be a root. So you have 2 times 1 is 2, 0 plus 2 is 2, 2 times 2 is 4. Okay, be very careful of this. Don't force it to happen. So if I have -3 plus 4, it gives me a 1. 2 times 1 is actually a +2, which gives me a 4. So that means 2 is not a root. So 2 is no good. Some of these you're going to try 2 and you're going to find the roots. Some you're going to have to try 8 of them. Okay? I can remember doing this in college and having a whole page full of all these possible roots and trying them and failing and trying them and trying them and on and on and on. Okay? And you're not going to be able to use your calculator. So we'll go back. We'll try 1. So 1, 0, -3, and 2. You want the same thing to occur. You want the 0 at the end. So we have 1 times 1, which is 1. 0 plus 1 is 1. 1 times 1 is 1. -3 plus 1 is a -2. 1 times -2 gives you the 2. All right, so that one's good. That one works. So what that means is 1 is a root. And then what you need to do is you need it to get down to an x squared. Once you get it down to an x squared, then you could use all these methods in the factor flowchart, or you can go right to the quadratic formula. Okay? But you got to be very careful as to what they're asking for. So remember, if I start with an x cubed, this one has what power value? X squared. So this is x squared plus x minus 2. To factor it, I have an x and an x plus 2 minus 1. So x equals negative 2, x equals 1. And I already have that original 1. So my solution set is negative 2, 1. Okay? And that is a double root, or it has a multiplicity of 2. Okay? Now, if it said to just factor it, you would have to leave it like this. Okay, I think some people on the quiz, it said to factor, and they went further. Okay, they solved for it. No good. Okay, questions on that? Woo! All right, here's the steps that you follow. Whoa. All right, finding the rational zeros of a polynomial, list the possible zeros, divide by synthetic division, and then repeat. So you repeat steps 1 and 2 for the quotient. Okay, and this is where it is. Stop when you reach a quotient that is a quadratic or factors easily. Okay, then use the quadratic formula or factor to find the remaining zeros. Okay, like I already stated. All right, so use the rational zero theorem to factor the following polynomials. First thing you have to do is list them. So it's plus minus. Factors of your C. What are the factors of the C term? More. 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 Thank you. 1, 2, 3, 6. Okay, you list all the factors. And then you list all the factors of the A term, which are 1 and 2. Now, the method I use is I will always take the values in the numerator and put them over each individual value in the denominator. So that way I have plus or minus 1, 2, 3, 6. It always starts out like that because the first factor in the denominator is always going to be 1. Okay? And then you have 1/2, which is just 1/2. Okay? You got 2 over 2. What's 2 over 2? 1. Already got it. Don't need to show it again. 3/2, you have to show it. 6 over 3, what's 6 over 2 is 3. You already got it. Don't show it again. Okay? So now look. There's 2, 4, 6, 8, 10, 12 possible roots. 12 of them. Okay? So I make them up. Okay? I could make it such that negative 3/2 is the root. Right? And then the rest are imaginary. So that way you got to go through test all these. Okay? It gets frustrating. Okay? But we'll see. Maybe. All right. So let's test. We'll just go in order. We'll start with 1. Okay. So we have 1, and we have 2, 1, negative 13, 6. 0, 2. I need this to be a 0. So 1, 2 is 2. 2, 1 is 3. 1, 3 is 3. Negative 10, negative 10. No good. Okay, it doesn't work. Okay, it doesn't give me that 0. So then I'm going to try 2. 2, 1, negative 13, 6. 0, 2, hopefully negative 6 and 0. So 2 times 2, 4, then we have a 5. 2 times 5, 10. Negative 3, there we are, negative 6 and 0. Okay, so that is one of the roots. 2 is. So then this is 2x squared plus 5x minus 3. Okay, if you want to go further, you're not going to have your calculator. All right, so you can't just do menu 331. So this one, I mean, since the A term and the C term are both prime, there's not as many to try. If you want to do the 2 times negative 3, get negative 6, and follow that process, you can. Okay, So that's negative 6, and somehow I will be able to get that positive 5. So what do I need? 2x, and I need a positive 3, negative 1. So I have 2x squared plus 6x minus 1x minus 3. And my values would be x equals 1/2 and x equals negative 3. Okay, so my roots would be 2, 1/2, and negative 3. Okay, now find all this, go all the way back, read what it says. Use the rational root theorem to factor the following polynomials. So I only want it factored. So here is the factored form of the trinomial, and then I throw next to it x minus 2, and then you tell me that this is your answer. Show me, circle it, box it, whatever. Okay? If you go further and find the zeros, that's fine. If you don't box it, then you're going to lose points. Okay, you got to make sure you write down exactly what they're looking for.
Okay, but how do you find the x minus 2?
Right there. See how that 2 is a root? Okay? So it's got to be x minus 2. Goody good? All right. List the possible roots for number 3. Just list them. List. Talk. You know what I'm saying? Do you? Don't forget plus minus. 1, 2, 5, 10. That's it. Okay, it's all over 1, so you want to show it, that's fine. And then you expand it, that's fine. Okay? Find one root. Start with 2. Don't check 1. So you tried 2, 2 didn't work. Okay, now it doesn't matter what you did next. I saw some people trying negative 2, I saw some people trying 5. It doesn't matter. Okay, 5. Keep going if you're working on it. Keep going. Is this what you're getting? All that? Is that 0 again? I get all this. See, this isn't working. What happened? What happened? What happened? 4, 3, 2, 1. Where? Here, 0. Ah, yes. There it was. Thank you. That's why we brought you in. There we go. Okay. So. Okay. All right. So this was a negative 5. All right. So once you have this remainder to be 0, okay, this is an x cubed. So you have to get down to an x squared. You got to do it again. Do not go all the way back up here. So just throw another value over here. Okay? So some of you already found the other value, right? It wasn't 5. What was it? What did some people find? What was another 0 you found? Negative 2. Yep. So if you have 5, then this one's going to be negative 2. If you have negative 2, this one's going to be 5. Okay? It will work. 1. No matter which way you do it, it doesn't matter. Whether you do the 5 first or the negative 2 first. Yes, they're both factors. And then what you're left with is x squared minus 2x minus 1. Okay? So we try to factor that. What are the factors of negative 1 that give me 2? There are none. Okay? So you leave this the way it is. Okay? Because it says to factor. Okay, if it said 5 to 0s, then you put it into the quadratic formula. So you have x squared minus 2x minus 1 times x minus 5 times x plus 2. That's it. Yeah. Yep. 2, 4, 6, 8. There's 8 things you can try. Yep. So, and sometimes you try all 8 of them. And guess what? Sometimes none of them work. I know. I know. Tell me about I've been there, kid.
So yeah,
I've been there.
Wait, so what is
Then you don't have any rational zeros, right? You know what I mean? So, very frustrating. Very frustrating.
yeah,
Makes you want to cry
like the
out loud. All right. At the end of class, you guys are going to try 4 and 5. I want to get the notes on Descartes' rule of signs. Okay? And this is what your quiz will be on soon. Probably Thursday for like 10 minutes. All right, now, Descartes' rule of sign. This tells you the number of possible positive roots and the number of possible negative roots. Okay? And it's all by the variations in sign. So when you look at the polynomial, okay, we're looking at this first polynomial. X squared is positive. 4x is positive. 1 is positive. How many variations in sign? 0. Okay? In the second one, 2x cubed is positive. X is negative. I'm sorry, positive. Hey. And 6 is negative. Hi there. Hey. Oh, come on in. Oh. All right, so here is my variation. It goes plus, plus, minus. Okay? So there's one variation of sign. Okay? This next one, I have plus. Here goes to minus. There's a variation in sign. Another negative. Okay, so from here to here it doesn't change. But then negative to positive, a variation in sign. So there's 1, 2. So there's 2 variations in sign. Now, when you're looking for the roots, it will always be the number of variations in sign decreased by 2. Okay? So you could have the number of variations in sign or that number decreased by 2. So that would be 2 or 0 possible roots. Okay? And that's what this says down here with the rule of signs. Positive roots, that's what we found right up above, is equal to the number of variations or less than by an even whole number, which the even whole number is 2. To find the number of negative real zeros, you have to plug in negative x. Okay, and find out how many possible negative real zeros there are. Okay? So, good old Descartes. Here we go. He is a good guy. Positive. Okay? So, sometimes it's easier to write positive, 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 negative, negative. Okay? So here you can see the variation in sign right there. So there is one possible, too many S's? Possible, okay? Positive root, couldn't tell. Okay? Now to find the negative root, you have to plug in the negative x. Now this is similar to our even and odd function, right? To determine whether it's even or odd, you put in the negative x. Oh my gosh, this thing. So you put in a negative x every single place you see an x. Now you don't always have to do that, but you have to show me the next step. Because remember, whenever you put it in for an even power, does it change? No, it doesn't change. Because if you have a negative x raised to an even power, it's going to become positive. Okay, it's going to stay the same. But if I have a negative x to the odd power, right, that becomes negative. So even power, this stays the same, 3x to the 6th. Okay, odd power, negative 4x to the 5th. Odd power, negative 3x cubed. Odd power, plus x, minus 3. Okay, does that make sense? So even stays the same, odd changes the sign. So my negative is positive, negative, negative, positive, negative. 1 sign change, 2, 3. 3 variations in sign. So that means it is 3 or 1 possible negative roots. Okay? And that's what Descartes is telling you. That's all. Use this in conjunction with the rational root theorem.
So this one is just about.
Yeah, that's all. because it's always decreased by 2. Okay? So this one here, positive, plus, 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 minus. How many are there? 1. Okay? 1 variation in sign. Okay, f of negative x, what happens to the x cubed? Yup, minus x cubed or negative x cubed. The x squared stays the same. The x, negative, and you got your minus 2. Negative, positive, negative, negative, 1, 2. So the negative roots are 2 or 0. Make sense? I think we might have been introduced to it. I didn't spend a lot of time on it, though. I think I did it kind of quick. You know? I don't know if I can't remember if we did an algebra 2 or not. What do you want? Okay. That's it? All right, and then try these last ones. Where are they? 4 and 5. Thank you, 4 and 5. Give those a whirl. Whoa, what was that? Oh, you're tired.